This lecture is a part of textile quality evaluation and also a part of fiber and yarn quality evaluation laboratory. Myself, Vishnuvardhani. Today we are going to see on cotton fiber length determination using the instrument Baersorter. Before going into the experiment, I will try to explain you the need for cotton fiber length testing. So, in general, like any other testing for any properties like length, fiber related properties, yarn related properties, or any fabric related properties, the general need for or reason for testing are to assess the product, to investigate whether there is some fault in the machines, to develop a new process or product, to do some research for variations in quality or any specifications regarding length or anything. So these are all common reasons for testing. And in the next thing, we'll see the specific reasons for fiber length measurement, or the importance or need for fiber length measurement, specifically fiber length. So they decide which is in a spinning mill whether to go for finer count or a coarser count. Based on the market survey, they determine that we are going to spin this count of yarn in our mill. So for spinning that count, what is the fiber that is required has to be selected. So the first and foremost parameter is fiber length. So in the market, when you go see, they will mention 2.5% span length, and the rate for this variety in this length of cotton is this much. So the fiber is selected based on its length. For a count to be spun, the fiber is selected based on its length also. There are other parameters also which you have to, or properties which you have to test, but the important parameter is fiber length. So so you decide which fiber length is required. So you will have 2-3 varieties of cotton. You will not use a single fiber variety for spinning yarn. You have to go for 2 or 3 mixings of two is usually common. So you can, based on the length, say DCH, MCU5 are 2 varieties of cotton. You mix those 2 varieties in blow room, and this mixing decision, how much percentage for the required quality of yarn, is also decided based on this length. So it decides the count, decides the cost of during purchase. You buy a raw material, and the raw material price is also based on the length. The better the length, the higher will be the price. So you for choosing the raw material, you need to find the length. Along with length, the other properties of fiber are also important. An important property is fiber length. So for deciding count decisions, cost decisions, mixing which variety of cotton to mix with, how much proportion, 40%, 60, 35, 40, 50, 50, or that proportion is also based on this length. So next, after this length, you are going to spin the yarn, and the yarn quality, which quality, this count, this much evenness if you want less hairiness, those things are based on your length. For the same count, you can use 2-3 different lengths, and the other properties are also based on your length. So longer your fiber, the ease you can process, and your quality of yarn and evenness of the yarn will improve, your fiber length improves. So for that also, fiber length determination is important. Next, you may sometimes get an approximate quality that is required, but the machine that you are running may have more breakages, and your productivity, there will be loss in productivity. So to get a higher productivity also, fiber length property is important. And next important thing is machine settings. Most of your machine settings are based on your fiber length, especially the draft roller settings. I hope you remember the draft rollers with three top and bottom rollers, the front nip and the back nip. So those things, the distance between the front and the middle roller, and this is called in front zone setting, and the middle and the back roller is called as back zone setting. And you may have four top for bottom rollers. Accordingly it will change. So the distance between the two nips is mainly based on your fiber length. It is usually 2.5% span length plus 2 or 3 mm, or nowadays they are using 5% span length of office as setting for those machines. So these settings are based on your fiber length. So you have to determine fiber length. And also other settings in the blow room card, comber, and the spacing between the um, nip, front roller nip, your top comb, bottom comb, all those settings are based on your fiber length. Next, the last thing is process control, whether the process is going on correctly, especially comber efficiency and is based on your fiber length determination, and the whether the carding process is happening properly, whether it's generating nips or not. Those things you can, whether it is generating some short fibers. Those things can be monitored only after measurement of fiber length. Whether there is need for card wire change, these things you can determine based on your fiber length. So this tells the importance or need for fiber length measurement, count determination, cost determination, mixing decisions, quality of yarn, evenness, hairiness, then machine conditions, breakage, productivity, machine settings, and process control. You need to go for fiber length measurement. So I hope you have understood the need now. Next we'll go to the methods of determination of fiber length. We have various methods for determination of fiber length. So first, when you take man-made fibers, it is very easy. Man-made fibers are cut to a specific length that is required. So it will be mostly uniform. There may be some uncut fibers. The double fibers may occur in double the length. So it is an easy method. You as mentioned here, and it is oil plate method for fiber length determination of man-made fibers. It is not a common practice because it is easy to measure fiber length and as it is uniform. The only difficulty is with natural fibers. So you oil plate method means a plate in which you pour some oil. We'll see it later now. Now we'll go to the, you can see the importance of fiber length measurement for natural fibers because there are many methods given. In earlier days, they were using hand stapling method, wherein they will take fibers and hand staple it. They will draft it, they will double it, draft it, double it, and based on their previous knowledge, they will determine the length. Next is comb sorter or Baersorter, which we are going to see now. And it is the instrument is slightly different for cotton and wool. As wool is of longer length, the spacings of the combs will be different. And next is Shirley. Then, as days passed by, Shirley photoelectric stapler came into existence, wherein they used electronic photo principle for determination of fiber length. Then came the fibrograph, and now commonly they are using HVI and also AFIS for determination of fiber length. The other methods like capacitance methods were also popular for wool fiber. For cotton, HVI and AFIS are very popular methods. But our concern for the determination of fiber length experiment here is comb sorter, because if you understand comb sorter better, those are all automated instruments. The principle behind the instrument and working behind those instruments can be well understood only when you understand comb sorter and how they determine the length in comb sorter, because the other methods only modifications in determination of the length is there. So one base instrument has to be understood, one manual thing has to be understood so that you can even appreciate the automated instruments. So the first is oil plate method. In oil plate method, as you know, man-made fibers, the variation is not there. Only double cut fibers may be there. So the fibers will be with crimp. So they are placed on, and this, consider this as an oil plate. See, this is an oil plate here. I'm drawing it again. This oil plate. In that you are placing the fibers. So you have to say, when I put it, it is irregular. So you have to, when in an oil, if you spread it, the crimp, first it will be with crimp. If you in the oil, if you straighten it, then it will be like this. So I'm not drawing it straight. I don't have the sufficient tools to draw it straight. You have to actually draw it straight and find the length here. And find the length. You can spread a number of fibers and find the length. This is called as oil plate method. And the oil used is paraffin oil usually, because the oil should not be absorbed by the fiber and there should not be any changes in the dimensions of the fiber. So this around 300 to 500 fibers are kept on the plate and measured, and for the actual length is measured. So it is a very simple method. They usually don't, this is not a common practice for determination of length of staple fibers. Only for some verification purpose they do it. Next is hand staple method. This is a very old method. Just when you get a sample, you take and know the length. It is an approximate one, as it is done by trained, it is given trained classes. Usually people who are more aware of fibers and who got trained on classing the fibers, classification of fibers based on the length, can do this. Earlier days, they will take such people to the market and they will check the fibers there and purchase the fibers. Now it is not a common practice. We rely on instruments now. But it is good that you get trained in the fiber so that you are not bluntly removing, bluntly accepting any result. So they are doing hand doubling, drawing. I hope you all know doubling and drafting, as you have already studied yarn manufacture, the card draw frame, doubling of 8 slivers and drawing in the draft zone happens. And this is done in short by hand, not as you do in the draw frame. You take a small tuft and do this and keep it on a flat background so that you can measure the staple length. So it is very subjective in nature and there will be differences based on the people who are classifying it. So it is not a reliable method. Next is determination of fiber length by Baersorter or comb sorter. So any experiment, you have already seen in the standards, there will be a scope, there will be definitions for the terms and other things. So all those things have to be understood properly before doing the experiment. So we'll see aim, how to prepare samples, what is the method. I'm not going to give details of the sample preparation. I will give it in a separate video on what is zoning technique. Next is what is the sample size, what are the instruments used for testing. This should have come in the next. The instrument used for testing, specifications of the instrument description, working principle of the instrument, procedure, calculation and expressions of result. In calculations, you have a sorter diagram analysis. These are the things that we are going to learn in the forthcoming slides. So the first one is aim of the experiment is to determine the fiber length and its distribution, because fiber length is not a single value, not a one value. You have a number of fibers, a group of fibers, not a single one. If I measure my height, it is a single value. If I measure the height of a class of students, then it is not a single value. So how it is distributed has to be known. So fiber length, it is not a single value. There will be variations in the fiber length, and how it is distributed can be found using this instrument. So the aim of the experiment is to determine the fiber length and its distribution. The standards that we are following here for determination of fiber length is IS 233 part 2, And the other standards related to fiber length are this. We are using array method here. It is described in ASTM. I hope you have seen in the website, the ASTM website, and what are the things that are there. And so the other standards for fibrograph is also given here. These are all related standards that we are not going to use here actually. We are going to use only in Indian standards for this experimental procedure. The properties that we determine, the properties fiber length, the parameters, you have additional things. When you go to a blood test report, you have n number of parameters that they are testing and giving. It is not a single value. Similarly, here we have for length, maximum length, mean length, effective length, short fiber content, and dispersion. These are the 5 things which you will importantly measure in this experiment. Maximum length, we will see the definitions later. Now I'm going into the sampling. You have to take a 20 milligram of fiber. Milligram is a very small amount of fiber. When you come to laboratory, you can measure and see how you can look into a 20 milligram of fiber. This is an exercise which you have to do in the laboratory. When you see a fiber, a bunch of fiber, you should be as a textile technology, you should be able to tell what is the weight of it. So you should be able to perceive and tell whether it is 20 gram or 100 gram. You should not have great differences in your weight. You should be able to understand how 100 gram will look like, how 1 kg will, volume of 1 kg will be. How you know your weight by seeing a person, you will be able to tell approximately he will be 50. You will not see a 100 kg person and tell it he will be 50 kg. Similarly, for fibers also, when you see a 100 gram, you should not tell it as 1 kg. This knowledge you should develop by weighing and seeing, perceiving the fibers. Next is the sample preparation is by zoning technique, not only for fiber length, for fiber fineness, fiber strength, maturity experiments, all you are going to use zoning technique. I will give the details of zoning technique in another video. Now we are going to look into the instrument description, and this is the Baersorter instrument. The total accessories are not displayed here. You can see the bottom combs. These are the bottom combs. There are 12 bottom combs. One end of the bottom comb is fixed here, and the other, you can see a rack here on this side. There is a rack wherein the bottom combs can be dropped one by one. This side is fixed and the other side can be dropped. There is a knob here. By adjusting this knob, each bottom comb can be dropped. This knob can be put on the other side also. This is the back side of the instrument, and this opposite side, you are looking on the back side of the instrument. There is another side, the front side, which is there is a it is slightly inward. The front side is slightly inward. The back side is towards the edge. Let us have a closer look of the instrument. Now, see, there are 12 bottom combs here, you can see, and there is a knob. By adjusting this knob, each bottom comb can be dropped inside this rack. You can see a rack. This is the rack, and these are the grooves wherein you can place the top combs. So this, where the grooves are there, this is the back side of the instrument. For identifying the back side, where the grooves are there, those are the back side. Don't keep this knob as an indicator, because this knob can be placed on the other side also. So where there are grooves, that is the back side of the instrument. So you can place the top combs in the grooves like this. Three top combs. You can see in this, the teeth is only towards one edge at this position, towards the left hand side, whereas the bottom comb has teeth throughout its length. Throughout its length, the bottom comb has teeth, whereas the top comb has teeth only towards one edge. See, you can see here only towards one edge there are teeth. This is a tweezer to pull the fibers and keep it in position. This is a depressor. You can see the grooves in the depressor. This is to position the fibers inside the combs. After using tweezer, you place the fibers on the combs, and using depressor, you will press the fibers inside. This is a velvet pad wherein you can arrange the fibers in descending order, for which this experiment is actually carried out. This is a velvet pad wherein you can arrange the fibers. This is a velvet pad wherein you can arrange the fibers in the descending order. This is a plastic scale kept on the velvet pad. This is used for tracing the edges of the arranged fiber. When we arrange the fibers in descending order, we can then trace that in this plastic scale. Now let us see how to do the experiment. There is a bunch of cotton fiber. The cotton fiber is taken from all the places, and you are taking a representative sample by zoning technique. After taking the fibers are kept in between the two hands as shown in the video, and you have to draft and double the fibers to prepare a representative sample. By doubling and drafting, you prepare a representative sample, and you turn the instrument such that the back side of the instrument faces the operator. Then you take the top combs aside and keep it on the left hand side like this. And then the prepared sample is kept on the back side, right hand side. Back side, right hand side, the fiber is placed like this. And then using depressor, the fibers are pressed inside the bottom comb. Now take the tweezer and pull the fibers and keep it on the left hand side of the bottom comb. Earlier back side, right hand side, now back side, left hand side. This is how it has to be placed, as such that the edges of the fiber starts from the first comb with the back side. Similarly, all the fibers are pulled and the short fibers that are combed nearby in the bottom comb and placed on the left hand side as shown in this video. Similarly, all the fibers are pulled and transferred to the left hand side. The purpose of this is to make the starting position of all the fibers the same. Earlier, the fibers started from different positions. Now, all the fibers start from the last comb. Using depressor, press the fibers. Using needles, take out the remaining fibers and also prepare that sample. Do not waste any part of the representative sample because it represents a great lot of fibers. So place it again, press using depressor, pull using the combs and comb it and place it on the left hand side. Transfer all the fibers from right hand side to left hand side. Now turn the instrument such that the front of the instrument faces the operator. Then place the top combs. 3 top combs are placed in its position in the grooves such that the needles are on the fibers. Because the top comb does not have the needles throughout, you place such that it is there. After placing all the top combs like this one by one, slowly the bottom combs are depressed one by one. See, the knob is adjusted and each bottom comb is dropped one by one, dropping the bottom comb one by one till you see the longest fiber that you have transferred. See the longest fiber, because the instrument is reversed, you will see the longest fiber first. So using tweezer, pull the fibers slowly, comb it in the needles that have been dropped, in the bottom comb that is dropped, and next place it in the velvet pad. So the longest fiber is first placed in the velvet pad, and it is pressed inside the velvet pad. Because it is a velvet pad, it will not move. Then the next bottom comb is dropped. The next tallest or longest fiber is pulled, combed by the tweezer, and then arranged nearby. So you are arranging the fibers in descending order. See, carefully and slowly and without any crimp, the fibers are placed. Since it is a velvet pad, it will not again form the crimp. The fibers will be straight. Similarly, all the fibers are taken and arranged in descending order. See, you are placing nearby, not on the same. Then till the end, similarly, all the fibers are being pulled. So the purpose of this experiment is to arrange the fibers in descending order or in an array form. Longest to the shortest fiber. Then after transferring all the fibers, a tracing paper is kept and the edges of the fiber are traced. Edges of the fiber ends are traced. We can use a plastic scale. Let us see the tracing once again. You are keeping the paper on that fiber array and tracing. Instead, you can use a plastic scale also and a marker and a whiteboard marker and mark the edges and then transfer to paper, which is an easy process. This is how it is traced. We can see the paths and description once more before doing the analysis of this traced diagram. We will see there are 3 top combs, there are 12 bottom combs, depressor, tweezer, velvet pad and plastic scale. We use plastic scale in our laboratory instead of that butter paper for tracing, which is a better tool for tracing. Next, top comb, bottom comb. The top comb has teeth only at one end. It can be removed and placed in position. Bottom comb is fixed at one end and the other end can be dropped by using a knob. The knob should be on the back side of the instrument. The back side can be identified by the grooves. On which side the grooves for the top comb are there, that is the back side. This is very important thing because if you place it wrongly, you will not do the experiment right. So depressor to push the fiber, press the fibers, tweezer to pull the fibers, velvet pad for arranging the fibers in a descending order, plastic scale to trace the sorter diagram. The procedure, 20 milligram of fiber was taken and it was doubled and drawn and kept on the back side, right hand side. Then it was pulled and all the fibers were transferred to the left hand side. Then the top combs were placed. The instrument was uh, faced such that the front faced the operator. Then by adjusting the knobs, the bottom combs were dropped one by one and till the longest fiber was seen. Then the fibers were pulled and kept on the velvet pad in an order. And this was the arrangement was is to be seen to that there is uniform density of fibers from the longest to the shortest fiber. And then after placing all the fibers on the velvet pad, the trace was done. We use plastic scale for tracing that. So the working principle, as you already saw in your procedure, the instrument helps in arranging the fibers, or an array is formed. The array is formed in descending order. In your school assembly line, you will stand in ascending order, whereas here the fibers are placed such that it is in a descending order and you are tracing that as your sorter diagram. The tracing the edges of that arranged pattern, that which is your sorter diagram. So this is how the fibers were sorted or arranged in an array form, for which the Baersorter instrument helped. After that, finding the parameters is by this analysis which we are going to do now. These are the parameters that you are going to find out of this instrument: effective length, mean length, short fiber percentage, dispersion. You can find maximum length and you need to understand upper quartile length to understand effective length better. Next, this is the sorter diagram which you have to draw out of the traced one. You would have got O, A, B, and now you have to do this. I'm now going to play the audio which was recorded during drawing the sorter diagram or construction of sorter diagram in Paint. This is the sorter diagram which you have got O, A, and B. After tracing, you have to mark the same notations: O here, A here, and B here. Now take a midpoint Q. From that midpoint, draw a line parallel to OB which touches the curve at P dash. So this is your Q and this is your P dash. From here, you are going to draw a perpendicular P dash which touches the curve at P. Perpendicular to OB, you are drawing PP dash. So here it is P. Here. Now take 1 by 4 OP. You are putting a point 1 by 4 OP which is K. 1 by 4 OP is OK. From there, you are drawing a perpendicular K dash to, you are drawing a perpendicular K dash to OB. I hope you are drawing along with me. So K dash, from K dash, take a midpoint of K dash. From there, draw a perpendicular to OB which touches the curve at R. Hope you are using a scale. And the R dash, just R dash. Anything on the curve is with dash. The same notation with and complementary dash. So from R dash, draw a perpendicular to OB which touches the curve or line OB at R. So mark R. So now from R, take 1 by 4 OR. Like OK is equal to 1 by 4 OK, you have to take OL is equal to 1 by 4 OR. Like if you can measure it, if it is some 4 inches, 1 by 1 inch is your OL. If OR is 4 inches, OL is 1 inch. So mark a point which is L, and from there you have to draw a perpendicular to OB L dash. So you are drawing L dash. This is your effective length. Now with this, almost your 80% is completed. Now similarly for OR, take 3 by 4 OR. 1 by 4 OR was OL and 3 by 4 OR is OM. So it will come here almost. So OM, from M, draw a perpendicular M dash. So M dash is perpendicular to OB. So for OR, OL is 1 by 4 and OM is 3 by 4. So this is your L. After L dash is your upper quarter, and below M dash is your lower quarter. So this distance is your interquarter. From L dash to M dash is your interquarter. So you are finding the difference of the interquarter by subtracting L dash from M dash. How will you subtract? So from M, draw a line parallel to OB which touches L dash at N. So L dash is the difference between L dash and M dash, which is interquarter range. So this interquarter range is less, then your dispersion will be low. So we have completed the construction of sorter diagram. LL dash is your effective length, below MM dash is your lower quarter, above LL dash is your upper quarter, RB is the short fiber. RB divided by OB will give you the short fiber content. We'll see each parameter definitions and the formulas to find the same using this sorter diagram. Now we are going to analyze this sorter diagram. The sorter diagram. I have not given the notation. Now we are going to this is the sorter diagram which you have got O, A and B. After tracing, you have to mark the same notations O here, A here and B here. Now take a midpoint Q. From that midpoint, draw a line parallel to OB which touches the curve at P dash. So this is your Q and this is your P dash. From here, you are going to draw a perpendicular P dash which touches the curve at P. Perpendicular to OB, you are drawing P dash. So here it is P. Here. Now take 1 by 4 OP. You are putting a point 1 by 4 OP which is K. 1 by 4 OP is OK. From there, you are drawing a perpendicular K dash to you are drawing a perpendicular K dash to OB. I hope you are drawing along with me. So K dash. From K dash, take a midpoint of K dash. From there, draw a perpendicular to OB which touches the curve at R. Hope you are using a scale and the R dash. It is R dash. Anything on the curve is with the dash. The same notation with the and complementary dash. So from R dash, draw a perpendicular to OB which touches the curve or line OB at R. So mark R. So now from R, take 1 by 4 OR. Like OK is equal to 1 by 4 OK. You have to take OL is equal to 1 by 4 OR. Like if you can measure it, if it is some 4 inches, 1 by 1 inch is your OL. If OR is 4 inches, OL is 1 inch. So mark a point which is L, and from there you have to draw a perpendicular to OB L dash. So you are drawing L dash. This is your effective length. Now with this almost your 80% is completed. Now similarly for OR, take 3 by 4 OR. 1 by 4 OR was OL and 3 by 4 OR is OM. So it will come here almost. So OM, from M, draw a perpendicular M dash. So M dash is perpendicular to OB. So for OR, OL is 1 by 4 and OM is 3 by 4. So this is your L. After L dash is your upper quarter and below M dash is your lower quarter. So this distance is your interquarter. From L dash to M dash is your interquarter. So you are finding the difference of the interquarter by subtracting L dash from M dash. How will you subtract? So from M, draw a line parallel to OB which touches L dash at N. So L dash is the difference between L dash and M dash, which is interquarter range. So this interquarter range is less, then your dispersion will be low. So we have drawn the sorted diagram. I have not given the notations here. It is yes. The midpoint of K dash which you have taken already is S. So the same notations you have to use when you draw the sorted diagram. So with this sorted diagram, we will do the analysis. Here L dash is your effective length. Above L dash is your upper quarter. Below L dash is your lower quarter. And this is your R dash B is your short fiber content. So you are ignoring the short fiber content. You are considering only the OR, and in that you have the lower quarter below dash and upper quarter above dash. So we'll see the further analysis later. The procedure what I described in the earlier slide is given here. So you can go through. And next we'll see the definitions for upper quarter length, effective length, mean length, dispersion and short fiber percentage. Now first is upper quarter. As per ASTM, the upper quarter is the upper quartile length is defined as the fiber length expressed by 25% of weight of the total fibers. So if you have 100 grams, the top 25% is your upper quarter, and according to your upper quartile length, you have the fibers are classified as short if the upper quartile length in is less than 27.9. If it is between 27.9 to 31.5, then it is termed as medium. If it is 31.8 to 35.3, then it is classified as long fibers. If it is greater than 35.3 mm, then it is extra long. Similarly, the classification of fibers based on 2.5% span length, based on effective length, based on staple length are also available. I want you to go through Citra notes for the classification of fibers by length based on various parameters got through various instruments. Now we'll try to understand upper quartile length. I'm going to play an audio recorded for understanding
upper quarter.
Quartile length.
From the word, you will be able to understand it is some quarter and an upper quarter. Say in a class, there are 100 students. The mark above which the top 25 students are there is called as upper quarter. Now let us try to understand the same with this diagram. So we have the total weight here of all the fibers as X. So this yellow color shows the total weight of all the fibers. Now we divide this into top 1 by 4 and bottom 3 by 4. So we have a line here where the upper quarter is there. This is your upper quarter. From here, the upper quarter is there. Then this will be then this part and this part. The total weight is X grams. Now this upper weight will be 0.25 grams I'm sorry, not 0.25 X grams, and this is 0.75% or 75% of X by weight will be this part, and this part is 20, and this length is your effective length. This length is your effective, I'm sorry, not effective length, this length is your upper quarter. That line which divides the upper quarter and lower quarter is your upper quartile length here. Quartile length or UQL. So this is your upper quartile. Now we'll understand the term effective length. Effective length is the longer than the average length. It is definitely above the average length, and it is a measure of the length of the upper group of longer fibers or majority of the longer fibers in the total sample. Then effective length is, it can be statistically told as upper quartile length. But it is the difference between upper quartile and effective length is you are ignoring the short fibers which are half than the length of the half uh, half by length. If the effective length is 1.5 inches, less than 0.75 inches is ignored and the total is taken, and you are going to understand effective length. Now I'm going to play the audio. Now we'll try to understand what is effective length. Now the same sorted diagram is taken, and in this, if you already know approximately some effective length and you are removing the length of fibers which are shorter than half of the effective length. I consider this is half of your effective length. Somewhere here is half of your effective length. Say if your effective length is here, this might be your half. So you are having half of your effective length here. And now this fibers by weight these fibers are removed. These fibers are removed. So this part fiber is now removed. This part is cut and it is removed. Now you are cutting this part and removing. This is removed. And now, so I'm moving it aside. Now this is taken, and you have this total weight. Consider this total weight to be x grams. Now this is x grams in total. Now this total is x grams, and you draw a line where the upper is here. It is in this. This is your 0.25 x grams. If the total is x grams, after removing the fibers less than half of your effective length, then this is your this here it is 0.7. Here 0.75 x grams. Hope you understand. After removing the fibers less than half of the effective length, the remaining portion total weight is taken, and the upper quarter is 0.25 x grams, and the remaining is 0.75 x gram. This line is called, this length is your effective length. This is your effective length. This is your effective length. Hope you have understood what is effective length. This effective length is very useful character, and this effective length is approximately your or statistically your upper quartile length after removing the short fibers whose length is below half of the effective length. If the term effective is used because this is the length which you used for your settings in your machinery, especially your draft roller settings. Then this also correlates well with your staple length. Earlier staple length was used by various type of classes who classified the fibers based on their effective length. We saw the classification based on upper quarter length earlier, and the classes classify fibers based on staple length, and this effective length correlates well with the staple length. But nowadays, due to advanced instruments, span length is used for these draft roller settings, and I hope you would have set the distance between the nips of the drafting rollers in your yarn manufacture laboratory in spinning draft frame and in speed frame as well. So next we'll try to understand mean length. Mean length is the average length of fibers. Two type of mean length is there: mean length by weight and mean length by number. We'll see the now we try to understand what is mean length by weight in this video. Now you are dividing into various length groups. You are dividing the total sorter diagram into various length groups. You are dividing into first length group, length above this, length, various length groups. You are dividing into almost equal length groups. So like this, you are dividing. Consider till the end, you are dividing like this. Okay, you are continuously dividing. I am not drawing it in total. So now this is your L1, length is L1, and this is your L2, this is your L3, and this is your L4. So, and this till the end it is Ln. So now consider the weight, this weight of the L1 length of fibers is W1. This W1 is the weight of that fibers, and next is this this weight of fibers is W2, and next is the third set, which is W3, and the fourth is W4. The weight of L4 fibers is, you cannot measure each and every length, so we are dividing into length groups. So now what, and this last one, let it be WN, the last one. It should be here. This is not LN. Here it is LN is here. This total, this one. So now, what is mean length? Mean length is equal to mean length by weight. Actually, it is mean length by weight. Mean length by weight is equal to W1 L1 plus W2 into L2 plus W3 L3 and till your WN LN. So all weight are included, and this divided by, you have this divided by the total weight. Yes, so it is a weighted average. So I hope you have understood the mean length by weight. Now
Now
we
I'm
are
going
going
to
to
play the
analyze the
audio for
sorter diagram.
understanding mean length by number.
Now we'll try to understand what is mean length by number. It is very simple. We have n number of fibers. Now we'll try to understand what is mean length by number. It is very simple. We have n number of fibers. This is the length of first fiber is L1. Next is we have n number of fibers. This, so let us see, this is the length of this fiber is L1, and this fiber is L2, and this fiber is L3, and this fiber is L4, and this fiber is L5, and this fiber is L6, and this fiber is L7, and many more fibers, and last fiber is Ln. So now the mean length by number is equal to L1 plus L2 plus L3 till Ln divided by n. That's it. So it is the sum of the length of all the fibers divided by number of fibers, but this is very difficult. We will be, in a bunch itself we will have many number of fibers. We can't take the fibers, each fiber, and weigh it. That is why we usually go for mean length by weight in many experiments. But in AFIS instrument, which has uh, provision to measure each fiber's length, that instrument alone gives.
So we'll now see what are the various parameters. Maximum length can be found in the sorter diagram, which is a measure of OA. It can be measured in inches, centimeter, or mm. And all the parameters you have to use the same value, or if you use inch for mean length, maximum length, then you have to use inches for mean length, effective length, and others. But if you use centimeter, commonly use the same scale. Next, the mean length. To find mean length, we had an understanding of mean length in the earlier slides. To find mean length in this sorted diagram, you have to find the area of OAB divided by length OB. Area of OAB can be found by using the adding the squares under the curve, as we will use inch graph sheet or a centimeter graph sheet. Inch graph sheet, it is easier to find the area under the curve, area of the OAB divided by length OB.
Next, we'll try to understand
I'm going
dispersion
to play
from
an
this
audio to understand
diagrams.
dispersion
So we
better.
have two sorted diagrams. Let us
Now
consider
let us
one
try to
like
understand
this. We
dispersion
have
better.
one sorted
Dispersions tell
diagram
about the
of
variability of
this
fiber or fiber length distribution. So we have two sorted diagrams here.
diagram.
You can
One
see in, let us consider this as A and this as B, as B. In A, we have the maximum
I'll
length
draw it
here
little more.
is, in A, we have the maximum length very higher and the maximum length is shorter here. So if we, now let us try to understand dispersion better. Dispersions tell about the variability of fiber or fiber length distribution. So we have two sorted diagrams here. You can see in, let us consider this as A and this as B, this as B. In A, we have the maximum length here is, in A, we have the maximum length very higher and the maximum length is shorter here. So if we have a sorted diagram like this, so we have LL dash here and your MM dash here. This MM dash. In this B diagram, we have your LL dash here and your MM dash here, which means that this is the lower quarter. We have our L, L dash. Here also we have L and L dash, L dash. Here is our M, M, and this is M, M dash. Here in this A we have M, M dash, M dash here. So now the dispersion is the difference between the upper quarter and the lower quarter expressed as a percentage of effective length LL dash. So now we'll try to understand that still more better. So we draw a line, in the construction we draw a line like this to find out N. So we found N to be here, and this we have our N here. So in this, our A or N L dash divided by L L dash, the dispersion is smaller here. N L dash is smaller here and N L dash is larger here, which means that the uniformity, you can see from the diagram itself, the uniformity for B is better than uniformity of A. So this range, so this many fibers, if you can keep common settings for both the for B, whereas if you keep A in your fiber, if you use a bunch of fibers, if you keep your length L1 plus 1 or 2 mm as your settings in draw frame, then all these fibers will go as floating fibers and it may catch any nip and it will cause unevenness in your yarn production. Whereas when you have this B type of fiber, if you keep, almost all these fibers are under control and only less short fibers will be there, or less floating fibers will be there, because short fibers you can remove in comber. Here, and how you will have, even if you have
L dash, I think almost 50 percentage will be here, which will be floating fibers. Here there will be no floating fibers, so unevenness will be very less. So it is better to choose B for having a uniform yarn. Now it is clear the formula for dispersion percentage is NL dash by LL dash into 100. LL dash is your effective length. NL dash is the interquartile range, and the percentage of interquartile range by effective length is your dispersion. So it tells about the variation of fiber, which is a very useful parameter about the fiber length. So the same here, if you have a flatter middle zone, then your dispersion will be minimum. If the dispersion is lesser, the value for dispersion is lesser, then your uniformity is higher. Next, short fiber content. We already saw the short fiber content is RB in your sorter diagram. RB divided by OB, the total length into 100 gives you short fiber content. This is shown here. Usually short fiber content also expressed by number and by weight. Short both are given in office instrument. Here we do not have by number and by weight. We find out short fiber content in Baersorter instrument by using the formula RB by OB into 100. So these are the results that you have to present for your Baersorter experiment: maximum length, effective length, mean length, short fiber percentage, and dispersion. Hope you have got an understanding on how to find all these things. We'll have a test shortly. And thank you for